Hello students, happy morning. We started learning about permutations and combinations. In the last class we have learnt what is fundamental principle of counting, or which is also called as multiplication principle. We found the occurrence of the number of ways of the occurrence of an event by multiplying the number of ways that particular event and the successive event can occur. For example, if an event occurs in m different ways and the successive event occurs in n different ways, then the total number of occurrences is m cross n. And we have solved problems also based on this. Yes, when the repetition is allowed, when the repetition is not allowed, all those things we have done. Next, we have learnt what is meant by permutation. Permutations of n objects taken r at a time. And we have seen it is n into n minus 1 into n minus 2 etc. n minus r plus 1. And since it seems to be so tedious to write every time, we introduced a notation called factorial notation. What is n factorial? 1 into 2 into 3 into etc. till n. We need to multiply all those numbers, and 0 factorial is 1. Alright, and we have solved problems based on this. So in today's class we are going to learn the compressed formula of permutation, which means NPR. We have seen NPR is n into n minus 1 into etc. till n minus r plus 1, right? So instead of writing in that way, we can write the same formula as n factorial divided by n minus r factorial. Why? Because in the numerator we need n from n to n minus r plus 1 only. So from n minus r till 1, the product will get cancelled with the denominator. Okay, so NPR, the derivation is not included in your syllabus, so you don't want to worry. It is enough if you remember the formula. NPR is n factorial divided by n minus r factorial. This is true for r equal to 0 as well. So NPR is n factorial divided by n minus r factorial, where 0 less than or equal to r less than or equal to n, under the condition the repetition of the things are not allowed. The repetition is not allowed. When repetition is not allowed, NPR is n factorial divided by n minus r factorial. Remember, when repetition is allowed, then NPR formula is n power r. When repetition is allowed, NPR is just n power r. And we are going to learn one more thing here. Number of permutations of n objects where p objects are of the same kind and rest of are all different. I mean, if you have, for example, say some word, the example which is given in your book is root. If you take the word root, O is repeated there, right? So even though there are 4 opportunities, if they ask you to find the various words that can be formed using the letters in the word root, and if you see O is repeated twice there, so it is like a same kind. So then the permutation, if it depends on the question again, if the position of O changes, it doesn't matter. The question, according to the question you have to think. Okay, so according to the question, and if the number of permutations of n objects where p objects are of the same kind and rest of are all different, then the number of permutation is n factorial divided by p factorial. Hope you understood. If the values given in the question are repeated, then n factorial divided by p factorial. While we solve problems, you will get a better clarity on this. Then in general, if we have, see, where p objects are of the same kind, if we have some set of objects are of the same kind and the remaining set of objects are of the same kind, then if you take the word independence, there 2-3 letters will repeat, right? So first letter, how many times it repeats? Second letter. Likewise, we can extend it for the general case. So n factorial divided by p factorial. So we have to remember all these formula. Permutations, number of permutations when repetition is not allowed, it is n factorial divided by n minus r factorial. When repetition is allowed, it is n power r. the number of permutations of n objects where p objects are of same kind, it is n factorial divided by p factorial, and it can be extended to the k number of terms, right? Let us solve problems from the exercise with this idea. The first question they asked is, how many 3-digit numbers can be formed? How many 3-digit numbers can be formed by using the digits 1 to 9 if number of digits, if no repetition is allowed, if no digit is repeated, right? That's what given in the question. How many 3-digit numbers can be formed using the digits 1 to 9 if no digit is repeated? So repetition is not allowed. So first understand what idea is given in the question and then proceed with your permutation formula. We are not going to perform this using multiplication principle. We have learned permutation, so you have to do with permutations only. If at all they mention in the question, perform it or find the answer using multiplication principle, you can go with that. Now come back to this. We have to form 3-digit number here and we have 9 digits. Repetition is not allowed. So it is like out of 9 items taking three objects at a time. Like right, out of 9 objects we are going to take 3 objects at a time. So it is like NPR. This is a direct question where repetition is not allowed, so you have to go with this formula. NPR is n factorial divided by n minus r factorial. This is out of n objects taking r objects at a time. So here out of 9 objects we are going to take 3 objects at a time because the repetition is not allowed. If I am going to fix 1 digit here, the remaining 2 digits will have less than 9 chances, which means this digit will have 8 chances, this digit will have 7 chances. It is like 7 into 8 into 9, right? So which is NPR. So n factorial divided by n minus r factorial, which is n factorial divided by n minus 3 is 6 factorial, and I am going to write 9 factorial as 6 factorial into 7 into 8 into 9. Then 6 will get cancelled, 6 factorial will get cancelled. So we got 7 into 8 into 9, which is 504. Hope you understood, right? Let us move on to the next question. Let us solve our next question. Is quite interesting. They asked you to find number of 4-digit numbers with no digit repeated. Number of 4-digit numbers with no digit repeated. So blindly you should not write it is 10p4 because 0 to 9 we will calculate, right? So 10 digits are there, so 10 digits taken 4 at a time. No, you have to analyze it properly. This is going to be a 4-digit number. So first digit, 1000th place should not be 0 there, right? 1000th digit should not be 0. So what about the remaining 3 digit? It can be any one among 0 to 9, and the repetition of the digits is not allowed. If we are going to fix any one number in our first 1000th place, then the remaining 3 digits, hundreds, tens and ones can occupy any one of the remaining digits only, right? So it is similar to fixing the 1000th place from 1 to 9 numbers, and the remaining 3 can take any one of the numbers from 0 to 9. And again, if you fix the second digit in your hundreds place, the remaining 2 digits cannot take up this, right? Therefore 1000th place, this is your 1000th place, and this is your hundreds, tens and ones, right? 1000th place. The 1000th place has how many ways? 9 ways, right? 9 ways to occupy a digit, because 1 to 9 digits, any one digit we can use. From 1 to 9 digit we can use any one digit in the 1000th place. In the hundreds, tens and ones place we have 0 to 9, right? 0 to 9. 0 to 9 we can fix up any one digit, leaving the digit which is fixed in the 1000th place. Leaving the digit which is fixed in the 1000th place. Why we should leave that? Because no digit is repeated. Yes, therefore again it has 9 chances only, because even though we have 10 digits, right? And when it comes to tens place, again we should leave the digit which is fixed here and here. So it will have 8 ways and it will have 7 ways. So the number of 4 digits with no digit repeated is same as the number of 3 digits with no digit repeated from digit 0 to 9. Yes or no? I repeat the procedure. We need to find the 4 digit number with no digit repeated. So we have 4 digits. When we talk about 4 digit number, the highest place value should not be 0. If the highest place value is 0, it will become a 3 digit number. So the highest place value, 1000th place, should be occupied with any one of the digits from 1 to 9 only. Right? So if we fix up any one digit in the 1000th place, then that digit should not be used in the remaining places, right? Remaining places, hundreds, tens or ones place, because it is given in the question, repetition is not allowed. So when we come to hundreds place, now how many options are there? We can fill in the hundreds, tens and ones place from any one of the digit from 0 to 9, right? Because 0 can appear in any one of the remaining places. So 0 to 9 we have 10 numbers. Out of 10 objects we are going to take only 9. Why? Because already one digit is fixed in our 1000th place. Right? Already one digit is fixed in our 1000th place. So there are only 9 options. And if you go to the 10th place, again already out of 10 digits, 2 digits are being fixed in 1000th and 100th place. So there are only 8 ways. And when you go to ones place, again there are 7 ways. So having number of 4 digit numbers with no digit repeated is same as number of 3 digit number formed using digits 0 to 9. So which means out of 9 digits we are using 3 digits at a time, right? So NP3, which is n factorial divided by n minus r factorial, which is n factorial divided by 6 factorial, again same as our previous problem. 6 factorial into 9 into 8 into 7 divided by 6 factorial, these two will get cancelled, which is 504. Hope you understood. Here we should not write 0 to 9. If we write 0 to 9, it will become 10 digits. So don't write 0 to 9. Number of 3 digit number formed using 9 digits. Number of you are formed using 9 digits is enough. Don't mention 0 to 9. If you mention 0 to 9, it will become 10 digits. There are only 9 opportunities since we have fixed one digit in our 1000th place. Yes. Hope you understood. Yes. Let us move on to our next question. Now let us see how can we solve our third question. How many 3-digit even numbers can be made using the digits 1 to 7 if no digit is repeated? See, it is very clearly given 7 digits. Out of that we are going to use 3 digits, right? But one more constraint is given in the question. It should be an even number. If it should be an even number, the ones place should be occupied by only the even numbers. So out of 1 to 7 digits, which are all even numbers? 2, 4 and 6. So the units digits are already fixed with 2, 4 or 6, right? 2, 4 or 6. So that is omitted now. So what is left out? Only 2 digits. 2 digits should be occupied. Out of remaining how many digits? 6 digits are there. Out of 6 we are going to have only 5 because one digit is being fixed in our ones place. So what is the answer for this? This is going to be 5C2, right? Hope you understood. See our third question. We have to frame a 3-digit number using these digits. In that it should be an even number. So ones place is fixed with 2, 4 and 6. Only if it is 2, 4 and 6 it will be a even number. So we need to bother about these 2 digits. So how many chances are there for these 2 digits to be filled in? 5 chances only, because we fixed 1 digit there and it is very clearly given repetition of digits is not allowed. Right? So out of 5 objects, now in our hand we have only 5 objects because one object is being fixed here. So out of 5 objects we are going to take 2 at a time. Therefore, which is nothing but 5p2. That's it, right? Now let us move on to our fourth question. They asked you to find the number of 4-digit numbers that can be formed using the digits 1 to 5 if no digit is repeated. And one more question they asked, how many of these will be even? So first let us find how many 4-digit numbers can be formed using these digits, which is simple because 0 is not included here. So we don't want to bother. 4 digits, out of these 5 digits we are going to take 4 at a time. So which is nothing but 5p4, right? But another question they posted here, they asked how many of these will be even. If it is going to be even number, again 2 and 4 only should be occupied in the ones place. So ones place 2 and 4 is fixed as the previous problem. So out of 1, 2, 3, 4, 5 objects, we have only 4 objects now because 1 is being fixed. So out of 4 we need to choose 3. So for even numbers we have, out of 4 we have to choose 3. So it is 4p3. Right? Hope you understood. Slowly you recall and analyze the things, you will get the answer easily. Don't do it in hurry. So let us move on to our next question. Fifth question is, I am leaving it to you as homework. From a committee of 8 persons, in how many ways we can choose a chairman and a vice chairman, assuming one person cannot hold more than one position. So it is like out of 8 objects, we are choosing 2 objects at a time and no repetition is allowed. Right? Here I can solve this. Let us see how can we solve our 6th and 7th question now. The next problem is find n if n minus 1 p3 is to n p4 equals to 1 is to 9. So it's like a ratio, right? So n minus 1 p3 ratio can be expressed as fraction divided by n p4 equal to 1 by 9. Apply your NPR formula. What is NPR? N factorial divided by n minus r factorial. So here in the place of n we have n minus 1. So n minus 1 factorial divided by n minus r factorial. So n minus 1 is your n minus 3 factorial divided by n factorial divided by n minus r factorial equals to 1 by 9. So what is n minus 1 minus 3? N minus 4. So if this will become reciprocate, right? So n minus 4 factorial will get cancelled. So again n minus 1 factorial, denominator we have n factorial. N factorial can be written as n into n minus 1 factorial. So again n minus 1 factorial will get cancelled. So 1 by n equal to 1 by 9 or n equal to 9. Yes, this is mere application of your NPR formula and simple calculations. Now let us see the next question. Next question also should be solved in the same way. They asked you to find R. Okay. Let us apply the formula. What is NPR? N factorial divided by n minus r factorial, which is equals to 2 into n factorial divided by n minus r factorial. You have to be careful because we have r minus 1 here. So which is equals to 2 into 6 factorial divided by 6 minus r, 6 minus into minus, it will become plus 1. Right? And this is 5 factorial divided by 5 minus r factorial. So which is 5 factorial divided by 5 minus r factorial, 2 into 6 factorial divided by, this is 7 minus r factorial. Right? Now 7 minus r factorial can be written as, first go to the numerator. This is 5 factorial divided by 5 minus r factorial, 2 into 6 factorial can be written as 5 factorial into 6 divided by 7 minus r factorial can be written as 7 minus r into 6 minus r into 5 minus r factorial. Right? So 5 factorial will get cancelled. 5 minus r factorial will get cancelled. So what we have now, 1 is equals to 12 divided by 7 minus r into 6 minus r. So this is what we got in our last step. 1 equal to 2 into 6 divided by 7 minus r into 6 minus r. Cross multiply and multiply each and every term. Bring this 12 to the other side. We got a quadratic equation. Factorize it by splitting the middle term. Yes. So we got r minus 10 into r minus 3, which is nothing but r equal to 10 r3. We have to choose the value of r. How can we choose? We have a constraint in the formula for NPR which says r should lie in between 0 and n, not in between equal to also. 0 less than or equal to r, less than or equal to n. So we have 5PR in the question. So r should be less than or 0 less than or equal to r less than or equal to 5. So r cannot take up the value 10 and hence r should be equal to 3. That's how you should give your conclusion. Yes, I am leaving the second subdivision in the 7th question to you. You can solve it in the same way. Let us see how can we solve the remaining problems in the exercise. 8th and 9th question, I am leaving it to you. Let us solve our 10th question. In how many way of the distinct permutations of the letters Mississippi do the 4 I's not come together? Understand the concept properly and solve the problem. See, there are different letters in this word. In that we can see the repetition of the letters. Here only we are going to use our last formula. Here I is repeated 4 times, S is repeated 4 times, P is repeated 2 times and M only once. The question is to find the distinct permutation of these letters in which these 4 I's should not come together. These 4 I's should not come together. That is what the question. So the idea behind in solving this problem is we are going to find the distinct permutations of these letters to be arranged. First we will find how many ever without any constraint we will find. After finding that, we are going to subtract the number of permutations where these 4 I's occur together. The question is the 4 I's should not appear together. What are we going to do? We are going to find the total number of permutations. From that we are going to subtract the number of permutations where the 4 I's occur together. Yes. So let us start our problem. We know the number of distinct permutations of the letters when a particular object repeat for particular time. What it is? N factorial divided by P1 factorial, P2 factorial, etc. Right? Now here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 objects. So 11 factorial divided by I repeated 4 times, S repeated 4 times, P repeated 2 times and M is only once. So leave it. So if you solve it and simplify, we are getting the answer as 34,650. Therefore, there are 34,650 ways for these 11 letters to be arranged in a distinct way to get distinct words. Alright, in spite of the position of these S and I. We don't know whether S and S will occur together. We have assumed it as a different objects and we have found our possibilities now. Now what are we going to do is we are going to find out how many ways these can be arranged in such a way that 4 I's occur together. So what are we going to do is when the 4 I's occur together, we treat it as a single object. So actually we had 11. So 11 minus 4 will become 7 objects. Alright. Now we have 7 objects plus we will take this as one object. So 7 plus 1, 8. So as of now we have 8 objects. Right. Out of these 8 objects, we have S repeated for 4 times and P repeated for 2 times. We leave I because we taken this as a single object. Right. So we have 8 factorial divided by 4 factorial into 2 factorial. How we got this? Using the last formula. N factorial divided by how many ever times the particular event occurs. Right. Repeated. So we are taking it as a 8 factorial because considering this 4i as a single object, 11 minus 4, 7. So 7 plus 1, as of now we have 8 object. Out of 8 object, S is repeated 4 times and P is repeated 2 times. So if we simplify this, we got 840. So there are 840 ways in which this 4 i's occur together. 4 i's occur together. And hence the number of ways where 4 i's do not occur together is total number of ways minus this 840 will give you your required answer. This is how only you have to solve this problem. Yes, hope you understood. If you have doubts, ask me, students. Don't hesitate to ask your doubts. Let us move on to our last question. Now let us solve our last question. It's quite interesting. They have given you the word permutations. They asked you 3 questions. In how many ways can the letters of the word permutations be arranged if words start with P and end with S is our first question. So the word permutation has 12 letters. As soon as you get a word, you should check for the repetition. And we can see the letter T appears 2 times. So repetition is there. So immediately which formula should strike your mind? The last one, n factorial divided by P1 factorial, P2 factorial, etc. And it is clearly given word should start with P and end with S. So the 2 positions is been fixed. The 2 positions is been fixed. Out of 12, these 2 positions is been fixed. Right? So we are bothered about the in between arrangements only. Right? So it is like out of 12, 2 is fixed. So 12 minus 2, 10. Out of 10 letters, we have to fill the remaining letters. Right? Therefore, the required number of arrangements is 10 factorial divided by, why this is 2 factorial? Since we are adopting the last formula, since we have repetition of letters here, n factorial divided by P factorial. T appears for 2 times. So out of 10 factorial, out of 10 letters, 2 letters are repeated. So n factorial divided by 2 factorial. If you simplify, you will get your answer. Now your next subdivision is vowels are all together. When you arrange the word, all the vowels should appear together. It is like the previous problem where we have seen all i's should appear together. So the same way we are going to solve this. Let us see how many vowels are there in the word. E, U, A, I, O. 5 letters are there. Right? So 5 vowels are there. So treat this as a single object. Treat this as a single object. So already 12 things are there. Right? Out of 12, 12 minus 5 is 7. 12 minus 5 is 7. So 7 objects plus this we are going to treat it as 1. So 7 plus 1, 8. This is similar to the previous problem. So out of 8 objects, we are going to treat it as 8 objects now. Out of 8 objects, we see the letter T appears 2 times. So it is going to be 8 factorial divided by 2 factorial. But with this we have stopped the previous problem because all were I. It doesn't matter in which position I appears. It is appearing in first position, second position, third position, it doesn't matter, right? But here we have different letters. Again, the arrangement of these letters also to be included there. So what are we going to do is, let us see how these 5 vowels can be arranged. These 5 vowels can be arranged in 5 different ways. This is like taking 5 objects, out of 5 objects taking 5 at a time, right? This can be arranged in E, U, A, I, O or U, A, E, I, O. Likewise, we can have many arrangements. So how many arrangements we will have? It is like out of 5 objects taking 5 at a time. So it is 5p 5 ways, which is nothing but n factorial divided by n minus r factorial, which is nothing but n factorial only. Np n is n factorial, right? So now we have by multiplication principle these many ways multiplied by these many ways. What does multiplication principle say? If we have 2 events to occur and one first event occurs in n ways and the second event occurs in m ways, and the total number of ways is n into m, right? So we have first the vowels. 5 vowels should appear together in 8 factorial divided by 2 factorial ways, and these 5 vowels should arrange in 5 factorial ways. Therefore, by multiplication principle, it is 8 factorial divided by 2 factorial multiplied by 5 factorial will give your answer. Yes. The last subdivision is always 4 letters between P and S. The letter P and S should be arranged in such a way there should be 4 letters in between P and S. So as we did in the same way, somehow the position of P and S is fixed. So let us find how many ways are there to get your arrangements. So there are 10 factorial divided by 2 factorial as we solved in our first subdivision. P and S position is fixed. So 2 positions are fixed. So the remaining are 10 factorial divided by 2 factorial. Why this is 2 factorial? Because T is repeated for 2 times. After this, there should be 4 letters in between P and S is given. Right? There should be 4 letters between P and S. So we should see how many arrangements can happen like that. So if I am going to fix P in my first position, then after 4 letters 1, 2, 3, 4, S will appear here. Right? So this is one way. So if I am going to fix my P here, what will happen? S will appear in 1, 2, 3, 4 and here S will appear. So if I am going to fix my P here, 1, 2, 3, 4 and S will appear here. If I am going to fix my P here, then 1, 2, 3, 4, S will appear here. If I am going to fix my P here, 1, 2, 3, 4, my S will appear here. If I am going to fix my P here, 1, 2, 3, 4, S will appear here. If I am going to fix P here, 1, 2, 3, 4, my S will appear here. If I fix my P here, I don't have space to fix my S. Right? So how many ways are possible? 1, 2, 3, 4, 5, 6, 7 ways are there to fix my P in such a way I will have 4 letters in between to fix my position of S. Right? Similarly, to fix my position of S, there are 7 ways to fix my position of P in leaving 4 letters in between. Hope you understood. Yes? Got it? So since they have given you 4 letters should be placed in between P and S, so we are checking how many possibilities are there. So 2 into 7 ways are there, which is nothing but 14 ways. 14 ways the position of P and S can be changed. So first we have found the number of ways the remaining letters can be arranged leaving P and S. Now we found in how many ways the position of P and S can be fixed. There are 14 ways to fix up the position of P and S. Yes, we found 7 ways to fix our P. The reverse way can also happen. We can replace P in the place of S and we can replace S in the place of P, right? We can do interchange. So again there will be 7 more ways. So 2 into 7, 14 ways are there. By multiplication principle, we have to multiply this with this. That will give you the answer. Right? Hope you understood. Initially you may feel it confusing, but if you analyze the question properly and think in each and every point of view, you can easily arrive at your answer. This is like your logical thinking. Every time we cannot go and list out all the possibilities and we can choose our required number of ways. So that way permutation plays a vital role in our everyday life and everyday situations. So it's quite interesting. If you think little bit, you will get your answer easily. So with this, let us wind up today's class and do these problems as homework, and if you have doubts, you can contact me. Thank you, students.